Okay, so good morning. We continue on trigonometry. We have looked at the trigonometric ratios, sine, cos, tan, secant, cosecant, and cot. We have looked at Pythagoras theorem. We've looked at the three sides of a right angle triangle, the hypotenuse, the adjacent, and the opposite, and how we can always identify them. All right, so today you look at we have something like sine 25, cos 76, tan 89. All right, we can always use our calculator, or we can always use the four-figure table to get it. So we have sine 25. Sine 25 is, I'm using the calculator, 0.4226. Okay, I'm putting it in four decimal places. That's the usual we do in mathematics. And then for cos 76, using the calculator, your scientific calculator, we have 0.2419. And then tan 89, we use the calculator, tan 89. Okay, now we can use the calculator, or we can use the four-figure table. Tan 89 will be 557.29. okay, 57.29. all right, tan 89 will be 57.289 as the case may be, or 57.29. okay, all right, so that's, we can always use the calculator or the four-figure table to find the sine, the cos, the tan, and from there we can always get the secant, the cosecant, and the cot of angles. But that's not really what I want to look at. In mathematics, we have what we call special angles. These are angles that we can always find their trigonometric ratios, I mean sine, cos, tan, and all that, without using the calculator. We can easily find them. Okay, we can easily, for example, sine 30 is 0.5 or half. I can show you how to find their trigonometric ratios without using the calculator. That's what I'm talking about this morning. Okay, so let's quickly look at special angles. What are the special angles I'm going to talk about this morning? We have 30 degrees, we have 45 degrees, and we have 60 degrees. Those are the special angles we are going to consider this morning. So let's start with 30 and 60. All right. We're going to start with 30 and 60. For us to find 30 and 60, we are going to use an equilateral triangle. Okay, all right, so we consider an equilateral triangle. What's an equilateral triangle? Is a triangle in which all sides are equal, all right, with sides 2 units. Okay, with sides 2 units. So let's draw an equilateral triangle, something like this. Just a sketch, 2, 2, 2. All right, and another thing about equilateral triangle is that the angles are equal. The angles are equal, and the angles are 60 degrees each. So this is 60, this is 60, and this is 60. Are you with me? And then we use we find the line that divides the angle, the triangle, into two equal triangles. I get what I'm trying to say. We use a divisor, an angle divisor. All right, we divide this into two. See what I'm doing? So immediately we do that, this is angle 90, this is angle 90. I get what I'm trying to say. It's going to split into two. So we're going to have something like this. Pay attention. We're going to have something like this. 30 degrees. Are you with me? Now, this is still 2. And these 2 now, we have divided into 2. Are you get what I'm trying to say? It now becomes 1, 1. So this is 1. Did you get that? So we projected a line, all right, that divided this angle and also divided this line. It's a bisector. Did you get that? All right, so now this is 2, this is 1. This is a right angle triangle. Okay, and this is 30 degrees, and remember that there's a 60 degrees there. Are you getting what I'm saying? So this is a right angle triangle. And then, excuse me, so that we can get, we need to get the three sides. We know this is 1, this is 2. We need to get this side x. And who can tell me how to get that side x from what we did last class? All right, we use the Pythagoras theorem. And what does the Pythagoras theorem state? It says that hypotenuse squared equals to opposite squared plus what? Talk to me. Plus adjacent squared. You see that? So what's the hypotenuse square here? This is 2 squared equals to, anyone can be opposite depending on the angle anyway, x squared plus 1 squared. So we have 4 equals to x squared plus 1. X squared equals to 4 minus 1. X squared equals to 3. That means x equals to square root of 3. Did you get that? Did you get that? All right, so that means what is here is square root of 3. So the hypotenuse here is 2. These two other sides are 1 and 3 respectively. Is that clear? All right, so from there we can find, the trigonometric ratios for 30 and 60. So let's start with 30. Let's consider 30. Pay attention. Let's consider 30. If this is 30, this is the opposite, this is the adjacent, this is the hypotenuse. We are considering 30 now. Okay, so we have something like this. Sine 30. What is sine 30? So katwa. I taught you last class. Sine is opposite of hypotenuse, cos is adjacent of hypotenuse, tan is opposite of adjacent. So sine 30 equals to what? Opposite. Let's go back there. Sine 30 is what? Opposite of hypotenuse. Opposite of hypotenuse. That will be 1 over root 3. Sorry, 1 over 2. Sorry about that. 1 over 2. Sine 30, opposite of hypotenuse. Okay, that will be 1 over 2. Are you getting what I'm saying? Sine 30 is 1 over 2. All right. So what will be cos 30? Adjacent over hypotenuse, right? So let's go back there. What's adjacent over hypotenuse? This is our adjacent. Okay. This is our adjacent. This is our hypotenuse. Adjacent hypotenuse. Adjacent hypotenuse. So that will be cos 30 will be root 3 over 2. Did you get that? So sine 30 is 1 over 2 or 0.5. If you use a calculator, you're going to get it. If you use a calculator, cos 30 is root 3 over 2 or 0.8660. Are you getting what I'm trying to say? All right. So the same thing. Let's try tan 30. Tan 30 is opposite over adjacent. What's our opposite? 1. What's our adjacent? Root 3. So that will be. Are you with me? That will be. Are you with me? That will be 1 over root 3. So that's the tan. Tan 30 is 1 over root 3. And so let's do that, something like this. Let's rationalize. Times root 3 over times root 3. Root 3 times 1, root 3. Root 3 times root 3, root 9. So root 3 over, what's root 9? Root 3 over 3. So tan 30 is 1 over root 3 or root 3 over 3. Is that clear? This is what we call rationalization. All right. So let's do 62. Okay, for 60, let's redraw the diagram. This 60 degrees is 30 degrees. This is root 3. This is 2 and this is 1, right? So for 60, cos 60 will cos 60 is adjacent of hypotenuse, 1 over 2. Sin 60 is opposite over adjacent. Opposite over adjacent, root 3 over 2. Tan 60 is opposite over adjacent. Opposite over adjacent, root 3 over 1. That will be root 3. So cos 60 is 1 over 2. Sin 60 is root 3 over 2. Tan 60 is root 3. Is that clear? Is that clear? Now let's quickly go through 45 degrees. 45 degrees. All right. We use a right angled isosceles triangle. All right, something like this, and we take it as 1 unit. 1 1. Are you with me? And because this is 90 degrees and its isosceles will be 45, this would also be 45, as the case may be. All right, so we need this side, which is the hypotenuse y. Okay, so we have, using Pythagoras theorem I taught you yesterday, y squared equals to 1 squared plus 1 squared, y squared equals to 1 plus 1, y squared equals to 2, y equals to square root of 2. So this is square root of 2. Are you with me? All right, so having done that, we are going to find the trigonometric ratios of 45. We can use either of the two. Okay, so we say sine 45 opposite over hypotenuse 1 over root 2. Okay, we can rationalize times root 2 over root 2. So that will be root 2 over root 4. That will be root 2 over 2. This is called rationalization. I've explained it earlier. So sine 45 is either 1 over root 2 or root 2 over 2. Cos 45 is the same thing. Adjacent over hypotenuse 1 over root 2. It's still the same thing as root 2 over 2. So sine 45 and cos 45 have the same values. Even if you use your calculator, you're going to have 0.7071. Okay, and let's look at tan 45. Tan 45. Tan 45 is, let's go back there, opposite over adjacent, 1 over 1. 1 over 1, which is what? 1. So that means we've been able to get sine 30, cos 60. Are you with me? Sine 30, sine 60. We've been able to get sine, cos, and tan for 30, 45, and 60 degrees. All right, sorry for that. And you don't need a calculator to get them. We are going to have questions that would require you to import the sort values of these angles without necessarily pressing 0.d, 0. that. You know, if you hear of sine 60, you should know sine 60 is root 3 over 2. If you hear of cos 30, you should know it's root 3 over 2. If you hear of sine 45, you should know it's root 2 over 2. We are going to, look at questions where that is necessary and where we are going to apply that. Okay, so that's that about that. Let me give you an assignment. The assignment is that now that we have gotten the sine, cos, and tan for 30, 45, and 60, I want you to get sec, cosec, and cot of all those three angles. Of all the three angles, find the secant, find the cosecant, and find the cot and the cotangent of 30, 45, and 60 degrees. And you can send the answers to me. All right, have a beautiful day. Thank you very much.